Hi, to my dearest student, let us continue with uniform acceleration. Okay? Hi, Madam Tan here. So let us continue with uniform acceleration. So what's meant by uniform acceleration? So same thing, I write the title first, uniform acceleration. Okay. So same thing, you imagine we have a car. This one imagine is a car. What is meant by uniform acceleration? Means along the journey, the value of A is actually maintain the same magnitude, maintain the same value. So for example, A equals to 5 meter per second square here. So along the journey is actually maintain the same value of A. Remember, acceleration is actually a vector quantity, means other than magnitude must be the same, the direction also have to be maintained the same. In this case, for example, it's moved to the right from side view. Okay? So if I want to know more about what is actually meant by uniform acceleration, it actually means that, like this, keyword is actually the velocity actually changing at uniform rate. Okay? Maybe you ask, actually what's meant by this sentence? Okay? So let's see. So means that if I want to look from the velocity, for example, at t equals 0 second, the velocity is actually 5 meter per second. And at t equals to 2 seconds, you will find that the v actually 10 meter per second. Okay, so same thing for the others. You will find that like this. At this point, 5, 10, next will be how? 15. That you observe some pattern from there. Almost similar to what we call uniform velocity just now. Okay? Sorry, this one 0, 2, so the pattern should be 4, right? 4, 4. And then here will be 6. If this one 5, 10, 15, so the next one will be 20. So we have v equals to 20 meter per second here. Okay? So this one actually means by uniform acceleration. Okay? So let us move on to the next part, which is graph. Okay? This topic, graph of motion for information, important. Okay? So let us see the more basic graph. For example, displacement time graph. This one for information, if you find that Madam write the symbol displacement, it actually means, see, if I write the symbol S, it actually means displacement. Displacement. So this one is actually displacement time graph. So let's look at more basic, okay, more basic pattern of graph. For example, a horizontal line which is along x-axis. Okay. So if I want to know for this graph, where is the position of our object, you will find that you see here, we try to analyze the graph. At t equals 0 second, the value of s, the value of s 0, right? 0, see here, at 0 second, our value of s 0. And then for example, at t equals to, for example, we take any positive value, for example, 0, this one 4, for example. Okay, what is the value of s? in this case, if I estimate what is the value of s here at t equals to 4, the value of s is 0, right? So what is mean by this? Your displacement, you will find that they maintain at the same point, even though the time changing already. Okay, means that the object, okay, if I illustrate the object at t equals to, see, at t equals to 0 second, the position of the object, for example, at this reference point, which is s equals to 0. Okay, and then even though the time passes, the s still maintain the same value of this one. So what does it mean? Means the object for this graph, the object actually stationary. What is mean by stationary? Dalam bahasa Pergun, objek kita tidak bergerak langsung. So you should know that the other keyword of stationary is actually doesn't move. It's actually bring the same meaning. Other than that will be, I think got another keyword but made them forgot already. Okay. Yeah. So that's it for this graph. So let's see another graph of S, which is, now I made them draw a horizontal line also, but now my horizontal line at this point. Okay, so let's see what is the difference between this and this. Okay, so same thing. Now we just read value from the graph. What does it mean by this? Means at t equals to, for example, 1 second, the value of s, for information, let's say, you should estimate this one should be a positive value. Okay, so for example, this one, 5 meter. So means that even though the time passes, the value of s still maintain 5. Okay, so let us illustrate what is happening actually. Okay, so let's say this one is an object. This one is our reference point, which is s equals to 0, our reference point here. Okay, but at t equals to 0 second, the object already at this position already. Okay, so means that initially pada awalnya objek kita sebenarnya dah at t equals to 0, at t equals to 0, our object dah pada kedudukan ini, which is the distance here I know is actually 5 meter already lah. Okay, means that our object dari awalnya memang dekat sini dah. Sebab apa? At time equals to 0, s equals to 5. And then as time passes, you see, as time passes, even at t equals to 4 second, our s how? Still maintain 5 meter. Maksudnya, adakah dia bergerak ke sana sini? Tidak. Dia masih mengekalkan kedudukan dia dekat sini. Dia, dalam case ini, dia juga tak bergerak langsung. Hanya beza dia dengan case pertama tadi adalah dari segi kedudukan dia lah. Untuk ini, kedudukan awal dan akhir objek ini adalah dekat sini. Tapi untuk ini, pada awal dan akhir objek ini, dia dah pada satu kedudukan di mana S sama dengan 5 meter kat sini lah. Okay? Never mind, if you don't understand, it's okay. We move on to the next part and see. Okay?